Hello students. So we'll be continuing with our pneumatic exercises. So last time we did we did exercise 1 to 3, right? So we'll be starting at 4 today. So from exercise 1 to 3, by now you should be familiar with the concepts of direct and indirect actuation, right? And some other concepts that I've also highlighted that you should understand. So now we'll be going more in-depth circuits. So it's very important that you understand the concept of exercise 1 to 3 and what they're trying to teach you, right? So without wasting any time, we'll start with exercise number 4, right? So exercise number 4, it's a it's filling plastic pallets, right? And in this exercise, you should be familiar with indirect actuation, logic operations. You should be able to select solenoid valve based on specific requirements, and then you should also be able to convert solenoid valve, right? So the description of the problem is saying the plastic pallets need to be filled from a storage silo, right? The silo is opened and closed with the flap, right? So something like this, right? And then they're saying the process will be started from 2 locations, right? And then the the description of the process is saying the flap is opened by pressing either one of the 2 push buttons, right? So flap is open by pressing either one of the 2 push buttons, right? And the bulk and the what you call and the bulk material is emptied out of the container, right? So here from this statement, right, what we can pick up is that like now that to open up our silo, right, we need 2 push buttons, right? So like this should be inform you of an or condition. So now let's say we're trying to control our what you call we're trying to control our side our flap from 2 positions, right? So we need 2 push buttons that do the exact same thing. So this is like a prime example of an or condition, right? So now they're saying when the push button is released, right, the flap is closed, right? So now the general conditions are saying a single acting cylinder will be used, right? And then the control of the cylinder will be actuated indirectly, right? Which means by means of a push button, which means we'll use indirect actuation, right? And then they're saying in the event of a power failure, cylinder's position should be the cylinder's position should be advanced to the forward end position. So this statement tells us if like there's a cut in current, right, the cylinder should always go to the advanced end position, right? Which means our cylinder initial position would be at the advanced end position, right? I hope you understand, right? So now moving on to our circuit, right? So they told us as one of the parameters that we'll use a single acting cylinder, right? And then so if you need a single acting cylinder, right, obviously you can't control a single acting cylinder with a you can't control a single acting cylinder with a 5-way, so you lose a 3-way, right? So these are the 3-ways that we have, right? But then if you go back here, right, to this statement, they said in an event of an electrical power failure, the cylinder should be at the forward end position, which means when there's no current in our circuit, the cylinder should always go to the forward end position, right? Which means here now we'll use the normally closed 3-way solenoid valve, right? So we take it here and then here, right? Which means we won't need this. And then we'll get our air service unit. We'll get our air service unit and our compressor, right? So our air service unit is to obviously filter out the air, and then our compressor is to provide air, right? So our service unit helps us provide clean air to the system, right? And then now we'll move on to the electrical circuit, right? So now I'll get my power elements, right? Okay, so actually I need, so now you'll rotate these ones by 180, right? And then you connect 24 to 24, then 0 to 0, right? And then now, since they said our cylinder will be controlled by either one of the two push buttons, right? Which means we'll need two push buttons that do the exact same thing, right? And one other thing before I start, like they said this control of the cylinder should be actuated indirectly, right? Which means we'll use a relay, right? So we get our relay connected here, and then obviously we'll need our solenoid valve, right? Anyway, like, so they said the cylinder will be controlled from either of the two push buttons, right? Which means you need to be able to control your cylinder from two positions, right? So now you'll use two push buttons. Coming back here, you'll take two push buttons, right? So now, since they said either, right? So either, like, it's another way of saying or. So the cylinder could only advance or retract by either, right? So we connect them in parallel, right? So we connect them in parallel like this. So now, if they said, like, for the cylinder to advance, you need to press this push button and this push button. We would have connected them in series. But now we're trying to control the cylinder's actuation and retraction from two positions, right? So now we'll have to connect them. We have to connect them in parallel to each other. So a parallel connection, it's similar to an OR condition, right? And then we'll get our changeover connected straight to power, and then back down, right? And then here, right? And then now we'll label our component, right? So now, as I said, this solenoid valve, it's actually here in real life, right? So if you want to see, like, how a 3-2-way with a solenoid is, and you can come to the lab and see it. But I also did show you in the first video, right? So you can also go back to the video if you don't have time to come to the lab. But anyway, right, so to indicate the physical connection, we have to label this as Q0, right? So now what you do is that to indicate the physical connection, right, you label this Q0, right? And then you also label your solenoid Q0, right? And then you label this Q0, right? And then to also, there's a connection between the solenoid and the changeover, so right? So now you also label this R1, right? And then you also label this R1. Right. So now, when the relay receives a signal from when you close either one of the two push buttons, right, the signal will be sent to the changeover, right, which will be then sent to the solenoid valve, right. And if you still remember, here they said our cylinder should be in the advanced position, in the forward end position, for when there's a power failure or when they cut current, right. And then now, so okay, before I simulate this, right, you can also label this as push button PB1, right, and you can also label this as PB2, right. So labeling is important. You'll see in later exercises why is it important. So now you simulate the circuit. So now you're starting in the advanced position, right, and then when you press the first push button, it retracts, and when you let it go, it goes back to this position, and then same thing. So they do the same thing. So now I can control the system from, as they said here, I can control the system from either of the two push buttons, right? And then every time when I let go of the push button, the flap is closed, which means the cylinder will snap back to its original position, just as happening now. So now that's your solution for exercise number 4. And then now moving on to exercise number 5, right? So exercise number 5, we are diverting packages, right? So now you'll be familiar, in this the objective of the exercise is to be familiar with the setup and functioning of a double acting cylinder, right? And you should also be familiar with the setup and function of a double solenoid valve, right? And then the third objective, we won't be looking at it much. We'll look at it like at a later exercise, right? So the description problem is saying packages will be diverted from one conveyor belt to the other by means of a diverter, right? And then the description of the process is saying the diverting gate is advanced when either of the two push buttons is activated, right? So as again, they're saying the diverting gate is advanced when either of the two push buttons are activated, right? And then they're saying the package is transferred and transported further, right? And then the next stage of the process, they are saying, oh sorry, I read the thing wrong. So they are saying here, right, the diverting gate is advanced when one of the two buttons is activated, right? So that's very important. They're saying when one of them is activated, the cylinder advances, right, and then the package is transferred and transported, right? And they're saying the diverting gate returns to its original position when the second push button is activated, right? And then the parameters are saying a double acting cylinder will be used, right? And then they are saying the cylinder will be controlled indirectly by means of a push button, right? And then they are saying in the event of an electrical power failure, the cylinder should remain in the current end position, right? So as I said, like, so if you cut current every time, the cylinder should remain in the current end position, which means it should remain in the position that it is at when you cut power, right? And then going back here, right? So here, if you read this statement, what you will pick up, right, is that there's one push button that advances the diverting gate or the cylinder, right? And then the second push button advances. The second push button makes the cylinder returns back to its original position, right? So they are saying a double acting cylinder will be used, right? So going back here, right, we get our, so we remove this and this, right? So we get our double acting cylinder, right? Then again, like going back to our statement here, right? They said the cylinder advances forward, right? They didn't say it goes back, right? The long time it goes back to when you press a second push button, right? Which means there's a latching mechanism keeping the cylinder in the advanced position, right? So what you'll do, right? You will use so now, as I said, so if you still remember, you can't control, for you to be able to control a double acting cylinder, you need a 5-way, right? So the trick here, right, it's selecting the proper 5-way, right? So here, if you look at this, and if I use this 5-way, since there's a spring load here at the end, the cylinder won't stay in the advanced end position, right? Therefore, we have to use, so, and one other thing, we can't use this 5-way solenoid operated valve, right? It's because we need two push buttons, one to advance and one to retract, right? So the appropriate 5-way solenoid valve tools would be the bistable 5-way solenoid operated, right? So now we remove this, right? So this side will make our cylinder advance, and since there's no spring load, it will stay in the advanced position, and then this one will make it retract, right? And then now you label, so now you connect everything, right, like this, and then you label this side Q0, right? And then you label this other side Q1, right? And then And then from here, right, from here, so our first push button, it's designed to make the cylinder advance, right? So this is gonna be our first push button, right? So now, since okay, so yeah, so now since this is our first push button, right? It's gonna be, so this first push button, in my case, I wanted to advance the cylinder, right? So push button 1 will make the cylinder go forward, right? So now this is gonna be the solenoid for this is gonna be the solenoid for this, right? Like this. So now okay, so okay, yeah. So now, so since I want this, so now the reason why I'm using indirect actuation is because here it was stated that the cylinder will be controlled by means of indirect actuation, right? So now going back here, right? So this first push button here, according to this statement, they're saying the diverter is going to advance when one of the push buttons is activated, right? So this is gonna be the push button that activates the cylinder to go forward. So now this push button is gonna be the one that activates Q0 this side to make the cylinder advance, right? And then now for our second push button that's gonna make the cylinder should be connected to Q1, right? But indirectly, right? So now we get our second push button here, right? And then we get our changeover and then our solenoid valve, right? To here, right? And then now we need our relay. So now what will happen is that now when you press this push button, right, the cylinder would advance to this other side, right? And then when it advances to the other side, right, we'll need a second push button that's gonna be act as Q1, right? That's gonna send a signal to Q1, right, for us to retract. So now our solenoid here is gonna be Q1, right? So it's gonna send a signal. This push button, you wanna make it, you're gonna connect in such a manner that now when it's advanced, this second push button is gonna help us retract the signal. So this is gonna be our PB2, right? And then this is gonna be our relay number 2, right, which is connected to this relay, right? So now when I press this push button, the cylinder would advance, since like the signal goes to R1 and then R1 sends a signal to the changeover setting it to close, and then current is going to be sent to Q0, right? And then hence the cylinder would advance. And then similarly, when the cylinder is advanced, when you press this push button, it will send a signal here, and then the relay will send a signal to the changeover switch to allow current to flow into Q1, making the cylinder retract, right? And then now, when I start, okay, so now I need to, so it's important that you address these errors every time, right? So now, okay, so now let's try that again. So now, when I press this push button, my cylinder advances and stays advanced, right? Right? And then now when I press second push button, my cylinder retracts, right? So now I've fulfilled the requirements of the exercise, right? So now let's say now, so if my cylinder's advanced and there's no power in the circuit, right? My cylinder is able to stay in the position where it's at up until I press the second push button to make it retract, right? So now I'm controlling my diverting gauge using two push buttons. One is used to advance and the second one is used to make the cylinder go back to its initial position, right? So now we'll move on to exercise number number 6, right? So in our exercise number 6, right? So you should be able to allocate components of an electropneumatic control system, right, to the pneumatic end or electric diagram. You should be familiar with the setup and function of a limit switch, right? And then you should also be familiar to one of the options for end position sensing in cylinders, right? And then you should be able to prepare switching elements for relays, right? So now they are saying here, wooden boards need to be pushed out of a stacking magazine into a mounting device, right? So this is what the process looks like, right? And then they are saying here, they are saying the cylinder, a cylinder advances, right? A wooden board is pushed out. Sorry, yeah, they're saying a wooden board is pushed out of the stacking magazine with a slide after pressing the push button. After reaching the front end position, the cylinder returns back to its initial position, right? So now, here, and then they're saying the cylinder's front position needs to be set, which means you need to detect the front end position of the cylinder, right? So now, as I was saying, right, so they're saying here the front end position needs to be sensed, right? So they're saying a wooden board is pushed out of the stacking magazine, right, with the slide, after pressing a push button, right? And then they're saying after reaching the front end position, the cylinder slides back to its initial position. So now, if you look at this statement, the cylinder doesn't slide back because of the spring load of the 5 it slides back as an effect of it being able to detect the front end position, right? So here, we'll still also use a double acting cylinder, right? But now we also need to sense the front mechanism, right? So since now, like, we also need to, we need to detect the front end position, right, for us to return, right? We'll use a bistable here, right, so that our cylinder doesn't snap back because of the spring force or the spring load. It only snaps back because it detects the front end position, right? So now, this push button, when you press it according to this, it's gonna make the cylinder advance, right? It's gonna make the wooden board push out, so it's gonna make the wooden board push out a workpiece out of here, all right? And then it is saying, also said, when the cylinder reaches the front end position, that's when it will retract, right? So now, this part of the circuit, so if I stop this, right? Okay, yeah. So now we'll need a electromechanical switch, right, to detect the front end position, right? So now what we'll do is that we should be able now to detect the front end position, right? So now what will happen is that here, right, how we detect the front end position, we're gonna get a distance ruler, right, to detect the front end position here, right? And then you're gonna label this maybe front position, right? And then our front position is at exactly at 100, so it's gonna be 100 to 100, right? So now this is our front end position, right? And then now what we'll do, right, to label this, we'll need a changeover, right? So this is us detecting the front end position using an electromechanical switch, right? So I'm going to teach you two ways. The first one will be using an electromechanical switch, and the other one will be using a proximity sensor, right? But now let's start with the with the electromechanical switch, right? So with an electrical mechanical switch, you're gonna take a changeover here, right? You're gonna connect it to the relay, right? And then now this electromechanical switch will be the front position, right? So now you label this as the front position, right? Like this, right? So now this will close every time when it's at the front position, and when it closes, it sends a signal to the relay number 2, right? Which in turn sends a signal to the changeover, making it close, and then the signal is sent to Q1, right? And then making the cylinder retract, right? So now if to simulate this, cylinder advances, and then you can see like every time the cylinder reaches the front end position, this side or this changeover turns on, right? And then causing the cylinder to retract, right? So now the cylinder is retracting as an effect of it detecting the front end position. And then the second way, right, that you can use to detect the front end position, right, or to detect positions, right, you can use a magnetic proximity sensor, right? So how we use a magnetic proximity sensor? Now we remove this, right? So this is what a magnetic proximity sensor looks like, right? And then now, okay, let me just make some space. Yeah, that's perfect. So now you connect this to power, right? And then you connect this back to ground, right? And then you connect this to the relay, right? This relay that sends a signal here, right? And then now what you'll do is that you label this sensor as the front end position, which means now this sensor, it's here at the front end position. So now since you want to you've labeled this sensor FP, means now it's located in the front end position, right? And then now, as you can see, every time it reaches the cylinder reaches the front end position, sensor becomes activated, and then making the cylinder retract, right? And then now that's it with exercise number 6, right? And then moving on to exercise number 7, right? And you also need to you need to be able to do a control system sequence of this circuit, right? So you should read up on that. And then now, okay, so this one is not important, right? So this is gonna be, so in exercise number 7, we're optimizing the inspection of beverage crates, right? So okay, so yeah, and then the disciplinary frame is saying the beverage crates are checked for completeness with the aid of an inspection unit, right? And then incomplete crates are pushed off the roller conveyor by a push button, right? Problems occur repeatedly with this setup thus far, right? And then the push button is not pressed long enough, and as a consequence, the single acting cylinder, right? It doesn't advance to the front end position, right? The beverage crates become jammed in the ejection area, right? And I think develop a controller with which this problem can be eliminated, right? So this is a process that they are talking about, right? And then they are saying the cylinder should advance as soon as a push button. The cylinder should advance as soon as a push button. Cylinder of a piston should advance as soon as a push button is activated. So don't worry about this, right? So yeah. So they're saying the cylinder should advance as soon as the push button is activated, right? And they're saying after the cylinder reaches the front end position, it activates a limit switch and it should retract automatically, right? So this is similar to what we just did, right? But they're saying a double acting cylinder will be used, right? And then what they're saying as well is that the control of the cylinder will be will be executed indirectly with push buttons and electromechanical limit switch, right? So for detect our position, our front and our back end position, we'll use an electromechanical limit switch, right? And in the saying advancing can only be started when the cylinder is in the rear end position, right? And then now, to ensure that our cylinder is in the rear end position, right? So okay, so now let's do. They said a double acting cylinder will be used, right? And then, what's this here? And then they said actuation will occur indirectly, right? So actuation, they said actuation will occur indirectly, right? And then they're saying advancing can only happen when the cylinder is in the rear end position. It can only advance when the cylinder is in the retracted end position, right? Which means now, our cylinder doesn't advance or retract. That doesn't retract because of a spring, right? So therefore, we'll continue using the bistable valve, right? So now, saying the first push button, right? So they are saying, right, if you look at this, they're saying the cylinder should only advance when the push button is pressed, right? So that's one, but what they are saying as well, they're also saying advancing can only happen when the cylinder is in the retracted end position. So which means for a cylinder to advance, we need to fulfill two conditions. There's us pressing our push button and in emphasis. So and the cylinder being in the rear end position, right? So now our cylinder would advance with these two conditions, right? So now first, when a push button is pressed, right? But we also need to detect when it's at the back end position, right? So now we'll label a position, right? We'll call it the back position, right? Which will be 0 and 0 at the rear end, right? And then now to fill that second condition, right? So let me just create space here, right? So they are saying we'll use an electromechanical limit switch, right? So let me just expand this side, right? Okay, yeah. Okay, yeah. All right. So now, as I was saying, right, we'll need to fill two conditions, right? They said the cylinder, if I can go back here again, right? They're saying the cylinder only advances, right, when you press the push button, right? And then under conditions again, they said advancing can only be started when the cylinder is in the rear end position. So we need a sensor to confirm that the cylinder is in the retracted end position. And they said here, right, we are supposed to use an electromechanical limit switch, right? So now, so in the previous slide, I showed you the different sensors, right? The magnetic proximity sensor and how to use an electromechanical switch, right? So now we'll get a changeover, right, which will act as our electromechanical switch, right? And then this changeover will be connected to another relay, right, which is we're gonna label R2. We're gonna label R2, right? So this is gonna be labeled R2, right? And then we connect this to power, right? And then what will happen is that now we'll label this. So now since we are trying to detect the back end position, right, we'll label this the back end part. So we'll label this BP, right, to detect the back end position, right? So now as you can see, it's currently closed because the cylinder is in the retracted end position, right? And then now to make sure that for a cylinder to advance, these two conditions are fulfilled, right? We want to add another changeover here, right, to here, right? And then we want to label this changeover R2, right? So now I'm sure now you can observe, like, so here, what we are saying, according to this, right? We are saying for our cylinder to advance, right? First, we need to send a signal to R1, right? So that it can close, right? And then this changeover needs to be closed as well, right? Or this electromechanical switch needs to detect the back end position as well, and to send a signal, so it sends a signal to R2, right? And then so it also closes, right? And that's the only condition, or that's the only point in which a signal will be sent to advance the cylinder, right? Using Q0, right? The side. So now these two conditions, this and this need to be fulfilled for the cylinder to advance. So if you look at this, now this, it's currently closed because the cylinder is in the back end position, right? And then even here you can see the signal has already been sent to R2 to close, right? Since this is in the back end position. And then when I press this, R1 will close, right? And then that's the only point in which a signal will be sent to Q0, right? Telling it to advance. So if now you observe, but now if let's say I'm trying to get it to retract, as you can see, R2 is not closing because the cylinder is not in the retracted end position, right? And then now to the second condition, right? They are saying the cylinder will, after the cylinder reaches the front end position, right? An element switch will be activated, or yeah, element switch will be activated, and then cylinder will retract automatically, right? Which means we need to make sure that cylinder when it reaches the front end position, it retracts automatically. So now here we've already defined our front end position as FP, right? And then again, one thing I want us to get, like they said, the control of the cylinder will be executed indirectly, right? So what will happen now is that we'll get a changeover, right, for the electromechanical limit switch here, right? And then back to here, right? And then now, oh, sorry, I made a mistake actually. We connect this to a relay, right, for our indirect actuation, right? And then goes back to the ground, right? And then now we label this to define our electromechanical limit switch, right? We'll label this now, since we are trying to make sure that when that is the front end position, it can retract, right? So we'll label this FP, right? So this is going to be the sensor that detects the limit switch that detects the front end position, right? And then now, if it detects the front end position, it will send the signal to relay number 3, right? And then now we're trying to get it to send a signal back to tell the signal to retract, right? So now we'll get our changeover, our dead changeover here to here, right? And then now this will connect to this solenoid, right? And then back to the ground, right? And then now this changeover, right? So now when the signal reaches the front end position, this would close, right? Sending a signal to R3, right? And then we're going to use this signal from R3 to send a signal to Q1 this side, right? To tell the signal to retract automatically, right? So now we'll label this R3, and then this will label this Q1, right? So it controls the retraction of our cylinder, right? So now if I simulate this, as you can see, every time it reaches the front end position, right, this switch closes automatically, right, to send a signal to R3, and then telling the cylinder to close, right, sending a signal to this side, right, making the cylinder go back to its null position. And then this one, it only advances with the aid of two conditions, like this and this. So cylinder has to be retracted, and you have to press a push button, right? And therefore you have to connect the relays that are connected to this and this. You have to connect them in series. So it's an AND condition, in a manner of speaking. So both. So this is yeah, as I was explaining, like in the context of circuits, right? In an AND condition, right? It's sort of like when you connect resistors in series, right? Both of them, or let's say bulbs. Yeah, let's use bulbs. If you connect the bulbs in series, right, for current to flow throughout the circuit, they both have to be on. Otherwise, current will not flow. And then in an OR condition, like you connect them in parallel, so current will take the part that's connected to, or the part that has power in it. Right? So here, for us, since we are trying to fulfill two conditions, right, we want to create an AND condition, right? Which means R2 it's used for detect the back end position with the aid of an electromechanical limit switch, and then push button it's for R1, right? So two conditions will be fulfilled, like in this man, right? And then moving on to exercise number 8. Moving on to exercise number 8, right? So you should be familiar with logic. So now you should be familiar with logic section and be able to set them up, right? And then here you should be able to to set up, and so now set up an electrical latching signal with a dominant break signal, right? So this is very important, right, for this exercise, right? A dominant braking signal, and you should be able to latch the circuit. So I'm just gonna highlight this. Like this might be the main purpose of the exercise, right? So now they are saying the screen is saying workpieces are transported on roller conveyors, right? Then one of the segments of the roller conveyor can be shifted with the aid of a pneumatic drive, right? And then they're saying this makes it possible to transfer workpieces to another roller conveyor, right? And then they're saying the process is saying the piston rod is advanced when you press push button, right? Push button 1. So this is just a way of them labeling this push button, right? And they're saying the cylinder is retracted when the second push button is pressed, right? So they're saying you should use a double acting cylinder, and the control will be done indirectly, right? So now, if we've gone through the other exercises, right? Exercises like this one, right? So so far we've been latching. We haven't been latching our circuit, right? We've been relying on the inner workings of the bistable 5-way valve, right, to latch the circuit, right? But here they're saying we have to be familiar with latching the circuit using a dominant braking signal, right? And then if you still remember, okay, so just make a diagram here. Yes, I can draw. Okay. So now if you still remember from when we were doing codices and serials, right? We used to have, let's say, our first push button here. Right? We used to have maybe P1, right? Or let's say P0. Let's say P0 is our start push button, right? And then now for us to latch, let's say would have maybe another push button, right, to stop the process, say P1. So our P1 would be our stop push button, right? And then we'll be maybe trying to turn on a particular output, right? Maybe let's say this is Q0, right? We'll be trying to turn on Q0, right? But for us to latch the circuit, right, we needed to connect this. We needed to be able to connect this Q0, right, in parallel with the signal or push button, right, that we are trying to use the signal of, right? Even if maybe let's say it's a sensor, right, we needed to latch like this, right? So now it's gonna send a continuous signal to the circuit, right? Or this is called latching or looping, right? And then now what will happen is that now we'll have a stop push button connected in the circuit like this, right? So when this push button was connected in the circuit, right, when you press the start push button, right, current would flow to Q0, right? And then it would be maintained because you latched you latch the circuit like this, right? And then as long as you've pressed Q1, that Q0 would be on, right? And then up until a point where you needed to stop the circuit, right? And then you press P1, right? P1 will have the capability to cut off the current going to Q0, right? So this P1, right? This P1, we can think of it as the dominant braking signal, right? Because it has the capability of cutting the current, right? And then now moving on to exercise, right? So now, since like this is latching, right? So okay, let me just remove everything here. So we start afresh, right? So now, since this has the capability to latch, right? We don't need to like. How can I put this? This has the capability to latch, and we don't need. I've been teaching you ways to latch it and then make it forward and retract. Similar. So now here, if we're trying to latch using a dominant braking signal, we can't have a bistable 5-way, right, which already has a latching mechanism built in, right, and then we come back to build a circuit, right, that has a latching mechanism as well, right. So now what we'll do is that now we'll use the spring-loaded one, right, that doesn't latch, and then we'll latch that signal to make it stay in that position, right. So now we wanna latch the signal of a spring-loaded 5-way, right. So now what you should do is that you should label this Q0, right? And then now going back here, saying when the first push button is pressed, the cylinder advance, right? And the second push button is pressed, the cylinder retracts, right? Double acting cylinder in direct actuation, right? And then now what you'll do is that you get the first push button here, right? So it's gonna be your first push button, right? And then now you connect this to your relay, right? And then now for you to latch, right? So since now this is the push button and then your relay is the output, right? You need to latch the signal of the output, right? So you ensure that the cylinder is able to remain in the advanced end position, right? Even if this 5-way is spring loaded. Right? So what you'll do is that you'll latch like this, right? So that it's able to maintain that signal, right? And then you label this R1 and then as well as R1, right? And then you label this R1 as well. And so now for you to send your signal to the output, right, you now get your changeover and then you connect it to you get this is a solenoid valve, sorry, and then you get your changeover and then you connect it back to here, right, and then you label this Q0, right. So now look at this, right, it's similar to what I just showed you now here, right. So what I did, I practically looped or latched the signal using the circuit, right, so that if I press this, current will go to Q0, right, and when current goes to Q0, it will also, now since I've created a loop between this and this, current will come here through this part, right, to continue to latch the circuit, right, or continue sending a continuous signal to the circuit, right, and then even if there's a spring here, right, our circuit should be able to remain in the advanced position, right. So we're gonna label this R1, and then now when I press this, our cylinder advances, right. But now how do we take it back, right? So now what we'll do, right, is that now they said when the second push button is activated, right, the cylinder will retract, right, and then what I'm trying to achieve familiar with is using a dominant braking signal, right. But now how do we make our cylinder retract from this circuit, right? So now we need to install S2 push button that's gonna retract the cylinder, right? But it's not gonna disturb with the functioning of the circuit, right? So we need a push button, right, that we're gonna connect here. So this is how you connect a dominant braking signal, right? So our is gonna be here, right, and then it's gonna be connected to here, right? So if you'll notice, right, I've used a brake push button, right? Or this push button, if you look at it, it's normally closed, right? So this push button, as soon as I press this, right, it will allow current will flow through it to the relay, sending a signal to the changeover and then making the sender advance, right? It will allow current to flow through it up until a point where I need to cut the current. Now I can just press it and then it opens up to cut the current and then closes back down, right? So now if you look at this, okay, so let me fix the, okay, and we are ready. So now if you look at this, current will flow through this push button, and then now since I've looped my circuit or latched it, right, current will take this part to here, right, and then it will pass through the push button to here, sending a signal to the relay, right? So since a continuous signal is being sent to the relay, right, this changeover will remain closed, and then therefore a continuous signal will be sent to Q0, which means air will be coming into Q0, right, keeping the cylinder advanced, right? And then up until a point where I need to cut the current with the second push button, right? So now I can just press this. So as you can see, it opened up for that instance that I press it, and then as soon as I let go of it, it closed back up again, right? So it's used to just cut the current in a circuit, right? So you can observe. So now I press this, current passes through it up until a point where I need to cut the current. That's when it retracts, right? So this is my first push button. This is my PP1. This is my PB2. And then that's how now you latch an electrical circuit, right? So one thing I want you to be aware of when you are latching, right? You can't get a bistable 5-2 and also latch here. So if you have to latch something, obviously a bistable comes with the latching mechanism, so you don't need to latch it. But if you are using a spring-loaded 5-2, solenoid operated 5-2, right, this is how you latch its signal, right? So you connect this. So you connect your push button, your input, right, in parallel with the output, and then you also put the output here, right? Similar to what we're doing when we're doing the logic programming, right? So this is not even similar; it's exactly the same. So you guys should understand this concept much more easily, right? And then now, so this is